Hey folks, welcome to part 2 of main logical operators. Hopefully you've watched part 1 of this series on how to find the main logical connective in LP, which is just a little review for you. And now we're going to focus on the logic of relations. In the logic of relations, we have our usual set of logical connectives, and then we have two other things that can be thought of as operators on a sentence. For all x, and there is an x. And here, of course, I've used x, but I don't have to use x. I'm technically using x as a meta variable that can take variables as its values, but forget about that if that just sounds puzzling to you. Basically, this could be for all x or for all y or for all z or whatever. Okay, let's look at some sample sentences and see if we can figure out a rule of thumb that will help us identify the main logical operator by inspection, as mathematicians sometimes say. So consider a sentence like this. And when we look at that, you could probably already guess that the main logical operator here, since now we're going to call all of these logical operators, the main logical operator is just that arrow. And let's contrast that with something like this. Here, as you can probably also guess from what we've done in class, the main logical operator is the universal quantifier. The difference can be brought out fairly quickly if we use an interpretation of the sort that we sometimes use in class. So for example, on the left, maybe the sentence says, if everyone is friendly, then everyone is generous. Whereas the one on the right says, all friendly people are generous. And you can probably convince yourself that those two are different sentences. So now, it's important to be able to identify the main logical connective because they're going to be treated differently in truth trees. And so, for instance, on the left, you already know what to do here just from your knowledge of truth trees from LP. This is just a material conditional. We're going to decompose it with the conditional decomposition rule. So we're just going to branch out like this, write down the negation of the antecedent, and then write down the consequent. But on the right-hand side, we haven't really talked very much about what to do yet. The rule for this is going to roughly say this. Look, this says something about everything. It says that for any x in a universe of discourse, this relationship holds. So if this is true for any x, it's true for any individual. And I can pick whatever individual I want to name, but the convention is to start with A, so I'm going to do FAGA. Or I could also pick a constant that already appears on the branch. Now, this is now going to go on to branch like this, of course, as usual. But here the left side and the right side are really different from each other, and we'll learn more about that later. But what we want to focus on today is how can we identify the main logical operator? Well, let me give you a couple of more examples, and then we'll try to build a rule of thumb that I hope you'll find really handy and easy to use. Let's think of something a little bit more complicated. Suppose we join the sentence on the left to the sentence on the right using one of our logical connectives. So maybe we want to write down for all x, if f of x, then g of x. And now we want to put the sentence on the right, so we need to put parentheses again. For all x, fx, then for all x, gx. Okay, well, what we notice about this sentence that I just wrote is that if I look outside all the parentheses, I see two things. I see a universal quantifier and I see a binary connective. And the answer here is going to be that it's the binary connective that is the main logical connective, as you would have guessed from the way we built the sentence, because we connected the two sentences up here on the left and on the right with the and symbol. That turns out to be a general pattern. If you ever see a binary connective outside all parentheses, that is the main logical connective. Of course, it can happen that there does not exist, or there does not appear, a binary connective outside all parentheses. For example, up here, right up here, we have a sentence. If we look outside all the parentheses, we don't see a binary connective, we see another logical operator. And there's only three choices for what kind of logical operator that can be. It can either be for all x, some universal quantifier, and remember it could be for all y or for all z or whatever. There is an X, or there is a Y, or a Z, or whatever. Or the other option is that there will be times when there are negation symbols out here. But if there's no binary connective outside all parentheses, then the main logical connective is simply going to be the leftmost logical operator. And it's as simple as that. So let's write that down so we can use it with some examples. And then we'll connect this to the truth tree rules. So this is for LR, or the logic of relations. And we're going to say that the main logical operator is either the binary connective outside all parentheses, or if there is no binary connective outside all parentheses, the leftmost logical operator. And it's that simple. So with this rule of thumb, I can write down any sentence in LR, and it might look very complicated and very scary at first, but it's really very simple to identify the main logical operator. So why don't we try a couple, and then we'll connect this to the truth tree rules, and you'll see why this makes a whole lot of sense. So let's try a couple of different looking sentences in LR. Okay, so we're in LR, and maybe we've got something like this. It's not the case that for all x there is a y such that if x Sx, then gy. Now, I mentioned already in class, we're never going to have to deal with sentences like this, but just as an example, let's sort of throw it out there and challenge ourselves to find the main logical operator. Or maybe we have something a little simpler. Somebody just says, it's not the case that for all x, Sx, then Px. It's not the case that all scientists are philosophers. Or maybe somebody says something like, there is an x such that it's not the case that Sx and Px. Okay, let's identify the main logical connective in each of these three cases using our rule of thumb. Let's maybe have one more. Sorry, we need one more example. Suppose we have for all x, it's not the case that for all x, Sx then Px, and there is an x, Sx. Okay, so now, our rule of thumb, you might have to look back, right, at your notes. If you're taking notes, right, it says the main logical operator is either the binary connective outside all parentheses, or if there isn't a binary connective outside all parentheses, the leftmost logical operator. Okay, so let's number these so we can refer to them. 1, 2, 3, 4. In number 1, what is the main logical operator? Is there a binary connective outside all parentheses? No. So then I look to the leftmost logical operator. That's the main logical connective. Sentence number 2. Is there a binary connective outside all parentheses? No. So I look to the leftmost logical operator. That's the main logical operator. Sentence number 3. Is there a binary connective outside all parentheses? The answer is no, because the negation symbol is not a binary connective. It's a unary connective. So then I look to the leftmost logical operator. So the main logical operator here is the existential quantifier. And notice, of course, we mentioned before that the existential quantifier includes the variable. Okay? Now, how about this last one? Is there a binary connective outside all parentheses? Yes, there is. It's right here. It's just that simple. So now, let's connect this to truth trees in LR, because our truth trees in LR are not going to be that much more complicated than our truth trees in LP. There's really just 4 more rules to learn. But as you can see, you can use all the tree rules that you knew before. So when we look at the kinds of sentences that you're going to face in a truth tree, you're going to face sentences where there's a main logical operator that is a binary connective outside all parentheses, right? And it might be an and or an arrow or an or a double arrow. Or the only, another option is that it'll be a negation of that kind of sentence. So these are all exactly the same kinds of rules that you used before. And now there's really basically only 4 more options. We might have a quantifier as the leftmost logical operator, and hence the main logical operator, for a sentence that has x as a variable. Or we might have an existential quantifier for a sentence that has x as a variable. And the only other 2 options is that it's a negation of a universal quantifier or the negation of existential quantifier. And that's it. So with the rule of thumb, you'll know which tree rule to use for whatever kind of sentence you encounter in your problems. Well, I hope this helped. We'll see you all soon.